All right, so we're going over 52 on page 180. I guess it's on page 183. Okay, I'm going to give you some hints on this, but I expect if you didn't do this, that after I give you some hints, you're going to want to go back and finish the problem. This problem this is an Algebra 1 problem. So let's talk through it, and I'll give you a couple quick reminders, and then I'm going to ask you guys to, if you weren't able to complete it or if you weren't sure what they were asking, to go back and finish it. So there's a doll making business, it has a weekly fixed cost of $350, and then materials cost $4.70 per doll. Total weekly costs average $500. How many dolls is he making each week? So when I read this, when I see that there's like a fixed cost, and then there's some amount that the cost is changing, and that change is constant, that makes me think this is a linear function. Okay, so we go in, and each week we got to pay $350, and then for every doll I make, my cost is going to increase a little bit. One more doll, another $470. Make another doll, that costs me another $470. So this is going to be a linear function. So we should be able to write an equation. Let's use f of x. F of x equals mx plus b to write an equation for this. And you guys dealt with linear functions a ton in Algebra 1 and reviewed them last year in Algebra 2. So I want you to kind of go through and be thinking about what is the change, so what is the rate of change, and what is the starting value or the y-intercept. So I'm going to let you guys finish that up. Once you get your equation written, you're going to have something equals something x plus something. X is going to represent in this how many dolls you're making. And then y is going to be how much your cost is in dollars. Once you have your equation, then you're just going to substitute a number in for either x or y. They're telling you that the total weekly costs average $500. Is that going to be an x value or a y value, that $500? That'll be a y value. So you'll stick the 500 in here, and you'll have a nice equation that you can then solve for x. Okay, nice two-step Algebra 1 style equation. All right, does anybody need any further hints on that one? You guys written down some notes to help you out with that? The answer to this is going to come out to be a decimal. I think we're going to want to round it though, because we can't make like part of a doll. So you can decide whether it's more appropriate to round up or down. I don't think there's one correct answer to that. All right, let's talk about 54. Finding maximum area. Okay, I'll tell you that this is very firmly an Algebra 2 problem. But it's the details are sort of hidden behind some geometry. So I'm going to help you kind of hopefully make the connection with some Algebra 2 concepts that you've learned. I'm not going to go through and do the whole thing for you, but I just want to point out some connections, and then if you need further hints, we can do that. So the idea here is that we have a rectangle, and it has a perimeter of 100 feet. So I'm going to draw myself a rectangle. And we want to maximize our area. So I don't know what the area is because I haven't chosen my dimensions for the rectangle yet, but I want it to be the max area that I could possibly do. So my strategy, what I'm thinking my strategy is going to be, is to be able to write an equation for the area. And then if I can get an equation for the area, then I should be able to graph that and figure out what's the highest point on that graph, and that should be my max. If I can do that by hand, I will. Otherwise, we've got a graphing calculator that'll do maxes and mins for us, right? So that's going to be my strategy for this, is see if I can write an equation and then figure out what's the highest point on that graph. So I want to try and write an equation for this, and I need to start choosing some variables. I'm going to say one of my sides is x, and then I need to come up with a value for the other side. Area is length times width, so I need something over here. I don't want to use a different variable, so I want to try and write this in terms of x. Way I thought about this was the following. I said if the whole perimeter is 100, then these two sides must add up to 50. Does that make sense? Those two sides would add up to 50. So let me shoot some numbers at you, and if I tell you a number for x, you tell me what the other side would be. So let's say x is 5. What would this other side be? 45. If x was 20, what would this side be? 30. If this x was 10, what would this side be? So when you're looking at numbers, you guys are good at telling me what these are. Now let's let x float. It's a variable. If x is x, then what would this be? What were you doing when I said x was 5? What did you do to turn that 5 into a 45 here? You did 50 minus the number I gave you, right? Did that work with the 10 also? If the x is 10, 50 minus 10 is 40. So if this is x, then I'm going to say this is 50 minus x. That's kind of how I thought through that. That was sort of my key step. From here, then you should be able to write me an equation for the area. It's just the length times the width. All right. Now, this is the part that I'm going to challenge you guys to go back, if you haven't done this problem, to start from here. And my challenge to you is you should be able to draw a graph of this equation without using your calculator at all. Okay? Yeah. So using your Algebra 2 skills, you should be able to make a graph of this thing. Now, if you're looking at this and you're like, I don't know what the graph of that looks like, think about some things that you could do. For example, you could rewrite this into a different form where you've distributed that x. If you were to distribute that x, I'm kind of seeing an x squared. Are you guys seeing an x squared? So what's that tell us about the graph of this thing? It's a parabola, and I think, is it going to be a positive x squared or a negative x squared? Negative x squared, so you're starting to get an idea of what this thing's going to look like. It's going to be a parabola opening downwards. You should know how to find the x-intercepts for that graph. You should feel confident doing that. Take this equation, set it equal to 0. That's going to tell you where your x-intercepts are. And once you find your x-intercepts, then figuring out this maximum point shouldn't be too difficult, because you know it's going to be halfway between these two things, right? So if you have not completed that problem already on your own, I'd encourage you to go back and use those tools that you developed last year in Algebra 2 to take another look at this thing and see if you can come up with the graph. And then once you've got your graph, that'll help you find. You're really looking for the vertex of this parabola, which is why this sort of fits into this section. All right. There's 54. Let's see, what was the other one? Oh, 73 to 76. Let me write down the information from 73 to 76 that you would need. This was given in the instructions. They told us that f of x is equal to mx plus b, so they're telling us it's a linear function. And they're telling us that f of negative 2 equals 3, and that f of 4 equals 1. So your job, in order to answer 73 through 70, or 73 and 74 anyways, you're going to need to figure out what m and b are. You're going to need to figure out the slope and the y-intercept for this thing. This is an Algebra 1 level problem. When they say f of I'm going to give my students a problem very similar to this in Algebra 1 in like 3 weeks, but I won't give them this function notation. I'll tell them that it goes through negative 2 comma 3 and that it goes through 4 comma 1. But I expect at this point that when you guys see something like f of 4 equals 1, that you can translate that to, oh, that goes through this point on the graph. All right, and if not, then moving forward, hopefully you will. And from here, if you're not sure how to come up with the slope from 2 points, and then use that slope along with one of these points to substitute back in and solve for b. If you're not sure how to do that, that's something that I would either do some independent research on or get my attention, and I'll work with you on that one. Okay, I've got some videos from last year from Algebra 1 I could point you towards, or I can give you some quick hints. Spoiler alert, it's a lot like what we did in our last example on Friday. Finding the b is just a matter of going back and taking that point, one of those points, and plugging it in for x and y in your equation and solving. So again, I'd be happy to help you through that if you need some assistance with that. Is there anything else from the assignment you guys would like to go over? I'm going to try and dial back on doing problems for you guys, and instead just offer some hints, because you guys sitting here watching me do a problem isn't going to help you learn. Okay. So, but if you go home and you try these over the next couple days and you're still having trouble, just let me know, and I can give you some more hints. Okay, we ready for new stuff? Yeah, all right. Hey, let's get into it. Power functions today. All right.